Transformers, more than meets the eye. That's right. Welcome to 3.3, where we're going to talk about function transformations. Let's talk about what that means. All right, so we're talking about function transformations, but like where are we at with that? So basically, we have these normal functions, and certain mathematical processes kind of move them around or change them in a very predictable way. So there are some distinct patterns. I alluded to them in our last section, but we're going to talk about them directly. Before we get started, we do got to kind of get some vocabulary out of the way. So we're looking at function family. So a family of function is a specific type of function. So we've got linear functions right here. Obviously, a linear function would just be a single line that can be any line going in any direction, things like that. So then we also have absolute value function right over there. So again, any kind of v is just going to be an absolute function, things like that. And we'll have parabolic functions. We'll have a whole bunch of different families of functions. But once we understand how those functions move, then we almost don't need to know as much about the function to figure out what the graph can look like. We just need to know what the parent function is, and then we can go from that. So a parent function is just like, if you were to have a very basic function, what does the most basic version of that function look like? So for linear, it's just a line going through the center, and it has a slope of 1, 1. So, you kind of have like a rise over a run there. So that is the parent function of a line. And same thing is true with the absolute value. It is an absolute value that starts in the origin and goes up at a 1 over 1 slope. So the parent function is just the basic function of where we start. So if we're looking at transformations, what this is asking us to do right here is, hey, let's start with an absolute value and see what these different things do to the graph. So I'm going to switch over to Desmos because that's a much easier platform to show you on. All right, here we are on the Desmos platform. I found it to be a lot easier to show these kinds of things. So we're starting off with our y equals absolute value of x. That's our parent function in red right there. So we're going to make a new function, but this time we're going to put plus 2, and what happens. So we can kind of see that it moved 2 units to the left. So note that 2 was on the inside of the absolute value. So it's hard for me to show it here, but these parentheses would be like those straight up and down bars. So, okay, what would happen if we put it on the outside? So we're just going to plus 2. So notice this time, this is the purple one, it moved up 2 units. So this is a distinct pattern. On the outside of the function, it moves up or down, and on the inside, it moves left or right. So then we can say multiply by 2. There's the black function right there. So it got squished a little bit. And let's do one more. What happens if we put a fraction out front? So I'm going to put that in parentheses. My parentheses did weird things, but that's okay. So this is the red one again. We're looking at this one right here. So notice that it got squished a little bit. So there's 3 different types of transformations that we're going to be dealing with. So let's label them all so we have a common vocabulary. So the 3 types of transformations that we have that we're going to talk about are these 3 right here. So we've got a translation. So those are our first 2. That's when the entire graph moves either up, down, or left or right. Nothing else changes. It just shifts left, shifts right, or shifts up or down. That's called a translation. So then we have a dilation. Dilation is whenever it gets squished or stretched. So like in our absolute value cases, we had one that looked like this, and then we had one that got really squished. That would be a dilation. So then we have reflection. I didn't show that one, but that's when we start with a function like this and it gets reflected about the x-axis. So our new function would look like that. So those are just the 3 words that we're going to be using to describe how these graphs change. Okay, so wouldn't it be nice if there was a list of exactly what a thing did and how it moved its graph? Oh my gosh, I agree. So this right here is the entire lesson. This is it. This is the thing. This is your key to doing everything in this entire lesson. So I'm going to highlight the whole thing. This is what you need to write down. So right now, pause the video and write this chart down. Is it written down? Good. This chart has all of your answers. So if we go through it real quick, so we've got our translations. So here we have that H, it's on the inside of the parentheses. So it's going to shift F H units. That means that whatever this number is going to go left that many units. So then on the inside of the equation right here, if it's a negative, it's going to shift right. So these two can get kind of confusing because, you know, if you think about positives and negatives, positive you generally think up and to the right if you look at your coordinate system. So when it's on the inside of the parentheses, it's opposite. So don't forget that it's opposite when it's inside of the parentheses. So here on the outside, it's kind of, it does go up and down, but it's a little bit more intuitive because when I think of up on the y-axis, I think of up. So positive would shift up k units, and then negative would shift down k units. So, okay, that makes sense. Dilations are a little wonky because they're harder to express in words, but the math kind of works out pretty okay. So we've got 2 situations. We're looking at this A right here. Sometimes this A is going to be bigger than 1. That's what that means. What that means is bigger than 1, not a fraction. I mean, it could be a fraction, but it'd be an improper fraction. In that case, it is a vertical stretch. So you saw earlier our absolute value became more skinny. So it got pulled apart up and down. If A is less than 1, so if A is less than 1, meaning that it's a fraction, it would be between 0 and 1. That's what this absolute value means. So A cannot be negative right now, but if A is less than 1, meaning it's a fraction, that means that the graph just gets squished. So in our example earlier, the absolute value looked kind of like that, whereas the normal, looked like that, whereas the normal one looked like that. So it just got squished down a little bit. And I said earlier, why is it not negative? So negative does its own thing, and that is it mirrors or reflects across the x-axis. So we're going to do a couple examples. We're going to see how all of that works. So let's get into it. So the majority of this unit is more about the analytical side. So it's looking at an equation and figuring out how did the graph shift and what happened to it. So we're going to focus on the analytical side, aka using words, as opposed to using graphs. You can always graph these things out. Desmos is a really good resource if you want to visualize how they move, just because it's easier to use than maybe your calculator. But remember, your calculator is allowed on test quizzes and the ACT. Desmos is not. But anyway, here we go. So we're looking at number 10. Our -3 is on the outside of the function. The absolute values, these little guys, kind of work as parentheses. So this is going to be shifted down 3 units. So shifted down 3 units. So I'm just going to go straight down. I guess this is the evens. So number 12 has 2 things that happen to it. We have a negative sign. Then we have -4 on the inside. So first, the -4 on the inside makes it shift to the right 4 units. So you'll notice that I hesitated here because inside is when things get weird and I have to switch it in my brain. So -4, it shifted to the right 4 units. So I'm going to put right 4 units. And then that negative sign reflects it across the x-axis. If you just put reflects, that would be fine too. So then we look at 14. There's a fraction on the beginning of it. So that a, so this part right here is kind of that a variable that we saw earlier from our chart. So that means that it's a vertical compression. So we would say vertical compression. I'm just going to write compress by 1/3. That's not a third. By 1/3. So that's kind of how you would write it. And then number 16, again, 2 things are happening. 3 things. So number 1, we've got our -1 on the inside. So it moves on the positive x direction. So it's going to be shifted right 1. Right 1. There's a 2 on the outside being multiplied in. So that means it's greater than 1. So it's a vertical stretch. Yeah, vertical stretch. Vertical stretch. And then that negative sign makes it flip or mirror or reflect across the x-axis. And then reflect about the x-axis. So 3 different things happen there from one kind of equation. So you can start to see how even if you didn't know anything about absolute values, you can start to get some information about how the graphs look and how the graphs move and change just by knowing this chart. Please make sure you know this chart. Okay, so we went from numbers to words. Now we have to go from words to numbers. So we are using an absolute value as the parent function. So remember that's f of x equals absolute value of x. It's a really great function that looks like right there. So number 18, it says translated 6 units to the right. So remember the x-axis is on the inside of the function, and that's the one that gets opposite. So I'm going to write f of x equals, we're going to open my absolute value, and it's going 6 units to the right. So we're going to say -6. So remember, inside of the function, the sign gets switched, and it goes left and right. Outside goes up and down. Speaking of up and down, so 19 reflected in the x-axis, then translated 2 units up. So we've got f of x equals, so it says it's reflected, so it's a negative sign on the outside, absolute value of x, and it said translated up 2 units. So on the outside of the function, we're going to do +2. So you can use that chart to go either way. Hint, you will probably be able to convince me to allow you to use that chart in some way, shape, or form on the test. You probably just got to figure out how you want to do that. But that chart is very handy until you get really, really used to this. So a couple more practice problems. So vertical stretched by a factor of 5. So f of x equals, so that means that 5 is going to go on the outside. Then translated 1 unit to the left. So left and right is on the inside, and inside gets switched. So there we go. We've got 5 times on the outside, x plus 1 on the inside. So 21 translated 3 units right and 4 units down. F of x equals absolute value of x. So inside is left and right. So it said 3 units right. So it's going to be opposite sign, 3 units right. And then 4 units down, not the opposite sign. So 4 units on the outside. 3 more. So this says a vertical compression by a factor of 2/3. Hopefully we're getting the hang of this a little bit. Then reflected on the x-axis. Well, should have read the whole thing, but that's okay. I can move that. So since it's reflected, I'm going to throw a negative sign out here, and then that's just absolute value of x. Make sense? Okay, 2 more. Vertically stretched by a factor of 2. Then translated down 9 units. So we're going to close that out, minus 9. Don't forget my f of x, I guess. And last but not least, vertically compressed by a factor of 1/4. And then shifted 1 unit to the left. Left x plus 1. So remember, on the inside of the function, the signs are opposite of what you would think. So again, this whole section is just about taking a general function or a general graph and seeing how it moves and connecting that to the different mathematical operations that we can do. You can apply these to any graph in existence, and you will see as we learn new graphs, you're going to see this stuff over and over and over again. So might as well learn it now. So this is parent function transformations. I will see you in class.